Hello viewers, welcome again to our lesson today. My name is Teacher Boni, a teacher of physics and mathematics. Our lesson today is a continuation on our topic force, Form 1. In our previous lesson, we learned about the type of force we are calling surface tension. And we said surface tension is a force which makes the surface of a liquid to behave like a thin, elastic skin. Something which is elastic is something which can increase in size and reduce in size at the same time. So the surface of a liquid, there is a force which makes it behave in that manner, that is elastic. At the same time, it is thin, so the surface of a liquid is behaving like something which can stretch. And we said this force has got several applications. And we said the force makes some objects be able to float on the surface. If you remember very well, we learned about an experiment where if you take a needle and place it on the surface of a liquid, the liquid is able, the needle is able to float on the surface of a liquid and without sinking. And we said that is possible due to the force we were calling it surface tension. And we said we have so many other cases which tries to apply the same force we are calling it surface tension. In my last point, we gave out some observations whose explanation is as a result of surface tension. Now, our today's lesson, we are going to look at the factors which affect surface tension, and then we shall also look at the last type of force, that is action and reaction force. Then we wind up our topic by looking at mass and weight. Now, factors that affect surface tension. Factors affecting surface tension. Factors affecting surface tension. We have two factors which affect surface tension. And this is a very common question, even to the Form 4s and Form 3s and Form 2s who are viewing this. You must be knowing the factors which affect surface tension. This is a very common question, which you'll commonly meet it in your exams. Now, we have two factors which affect surface tension. Factor number one, we have what we call impurities. Factor number two, we have what we call temperature. These are the two factors which affect surface tension. When you talk of impurities, what are impurities? Impurities are foreign substances in a liquid. Foreign substances in a liquid. Introduction of foreign, unfamiliar particles in a liquid. It makes the liquid to be impure. In other words, when we have a mixture of molecules of different kind, then that liquid becomes impure. Now, how does impurities affect surface tension? You'll find that the surface tension of pure liquid is different from the surface tension of impure liquid. So let's look at how do the two factors affect surface tension. Let's start with impurities. We have said impurities are foreign substances in a liquid. How do impurities affect surface tension? One, impurities lowers the surface tension. Impurities lowers the surface tension of a liquid. When you introduce foreign particles in a liquid, those foreign particles are going to lower the surface tension. In other words, the surface tension makes a liquid to be able to accommodate some substances floating on it. An insect will be able to float on the surface of water due to surface tension. But now, if you introduce a foreign substance in that liquid, then the surface tension will be lowered or will be weakened. How? If you have a basin containing water, we have learned that a needle is able to float on the surface of this water. Now, if you take an impurity, let's say we are using soap solution. These are needle floats on the surface of water due to surface tension. Now, this is soap solution. We are adding soap solution in the basin of water. When you add soap solution in the water, what happens? The needle sinks. The needle sinks on addition of soap solution. This is a common question you'll meet in the exam. This experiment, we are trying to demonstrate how impurities affect surface tension. In our first setup, this is a beaker. The beaker contains water. You take a beaker, put water in the beaker, then take a needle, place on the surface of the water. You find out that the needle floats on the surface of water. And the reason is, this is as a result of the surface tension. Now, part B, we are taking soap solution and adding in the water in the beaker. When soap solution is added in the beaker, you find that the needle sinks. That is now the needle. The needle sinks in the water. So the question is, what is making the needle to sink? The soap solution is making the needle to sink. Why? Now, the soap solution is an impurity in the water. And being an impurity in the water, we have said impurities do what? They lower the surface tension. So, on addition of the soap solution in the liquid, the soap solution lowers the surface tension of the water, and therefore making the needle to sink. Now, explanation. Why does an impurity lower the surface tension? How does an impurity lower the surface tension? This is what happens. Impurities weaken cohesive forces between the surface molecules. Impurities weaken the cohesive forces between the surface molecules, hence lowering surface tension. The impurities, those are foreign particles. Now, the foreign particles introduced in the liquid, the foreign particles are going to weaken the cohesive forces which are attracting the surface molecules. If you remember very well, we said what causes surface tension? Surface tension is caused by the cohesive forces of attraction between the surface molecules. Now, once the impurity, which is the soap solution, is introduced in the liquid, the soap solution is going to weaken these cohesive forces of attraction between the surface molecules. Once the cohesive forces are weakened, then the elastic skin surface of the water becomes weak. Because remember, the surface is made to be elastic because of the cohesive forces of attraction between these surface molecules. And once now foreign particles get in, they weaken these forces of attraction between this water molecule and this another water molecule. And once that force is weakened, then the strength which is making the skin to be elastic will be weakened, and therefore the needle sinks in the liquid. So this is an explanation of how impurities affect surface tension. They lower the surface tension. By doing what? The foreign particles weaken the cohesive forces between the surface molecules, hence the surface tension is weakened. That is how we explain how impurities affect surface tension. Our factor number two is temperature. Now let's look at what about temperature. How does temperature affect surface tension? Temperature increase lowers the surface tension. Temperature increase lowers the surface tension. That is how temperature, as our second factor, affects surface tension. When a liquid is heated, then the surface tension is going to be weakened. That means, in this case, our beaker containing the water, when the needle is on the surface, the needle is floating. If I start heating this beaker, I start heating the water in the beaker, then the surface tension is going to be weakened or lowered. And for that matter, our needle is going to sink. So temperature increase lowers the surface tension. And you must be also in a position to explain how. Explain how increasing temperature lowers the surface tension. This is our explanation. When you increase the temperature of a liquid, what happens is the particles of the liquid gain more kinetic energy. The kinetic energy of the particles increase. Once the kinetic energy of the particles increase, therefore, their motion, we call it Brownian motion, their motion from the movement from one part to another increases. They move much faster and more rapidly. This will increase their intermolecular spacing, because as they are moving faster, they will be moving far away from each other. And the farther they move from each other, they weaken the cohesive forces and it increases the intermolecular distance. This lowers the surface tension. So we write and say, increase in temperature increases the kinetic energy. Increase in temperature increases the kinetic energy of the particles. Increases the kinetic energy of the particles. Hence, increasing the movement of particles. This leads to increase in the intermolecular distances. Thus lowering the cohesive forces between the surface molecules. When you increase the temperature of the liquid, you are going to increase the kinetic energy of the particles. Increase in temperature increases the kinetic energy of the particles. Once the particles gain more kinetic energy, they start moving faster. And as they move faster, they move far away from each other. As they move far away from each other, they increase what you are calling the interparticle spacing. When the interparticle spacing increases, the cohesive force of attraction between the molecules is going to be weakened. And this lowers the surface tension. Remember, the surface tension is caused by the cohesive forces between the surface molecules. So if these particles are gaining more energy, then they are going to move faster. And as they move faster, they will be moving far away from each other. So you find out that this distance from one molecule to another is going to increase. If this one now moves from here to here, this distance becomes bigger. And when the distance becomes bigger, then the force attracting these molecules together will be lower. It becomes weak. Once it becomes weak, then the strength of the surface of the liquid, which is causing the surface tension, becomes weak. So, in short, temperature increases the kinetic energy of the particles. Increasing the kinetic energy of the particles increases the movement of the particles. Once the movement of the particles increases, they move far away from each other, therefore increasing the interparticle spacing. Once the interparticle spacing increases, the cohesive force of attraction between these molecules is weakened. Therefore, surface tension is lowered. So, Form 1s, Form 2s, Form 3, and Form 4. Remember, I said this is a very common question in your exams. You'll meet a question telling you to, first of all, state factors affecting surface tension. We have said we have two factors affecting surface tension: impurities and temperature. Number 2, explain the factors affecting surface tension. We have talked of temperature, and we have explained how temperature affects surface tension. We have explained how impurities affect surface tension. The explanation is very important because it carries more marks compared to stating. Now, another kind of question will come in a reverse way. You'll be told to explain how you can lower the surface tension. How can you lower the surface tension of a liquid? You can lower the surface tension of a liquid by introducing impurities and increasing the temperature. Explain how you can increase the surface tension of a liquid. We can increase the surface tension by purifying the liquid, in other words, removing the impurities. Number 2, lowering the temperature. A liquid at a higher temperature has got a weaker surface tension compared to a liquid at a lower temperature. All right. So those are the 2 factors which affect surface tension. Those are the 2 factors which affect surface tension. Now, our last subtopic on surface tension, consequences of surface tension, effects of surface tension. This is another common question we come across, effects of surface tension. State the 2 effects of surface tension. We have so many effects of surface tension. When you talk of surface tension effects, we already discussed them. We have 2 effects here. Number 1, you say water insects can rest on the surface of water, on the surface of water without breaking the surface, without breaking the surface, without breaking the surface. Number 2, mosquito larvae floats on water surface. I think these are common factors I've already talked about. We explained them, I talked about them earlier in our subtopic. Now, we have effects of surface tension. Water insects can rest on the surface of water without breaking the surface. We have what we call water skaters. We have insects which actually, they tread on the surface of water. They can run on the surface of water, crawl on the surface of water, but they cannot sink. They cannot break the surface of a liquid. That is an effect of surface tension. I talked of the mosquitoes. The mosquitoes normally lay their eggs on the surface of water. The eggs will later hatch into larvae, and the larvae will float on the surface of the water until they grow into bigger mosquitoes which can fly away. So the mosquito larvae lies on the surface of the water without actually breaking the surface of water. And we say this is as a result of surface tension. And you find that we can control mosquito breeding by introducing oiling the water surface. We know when you introduce the oil on the surface of the water, the oil is going to float on the surface of water. And the oil is going to be an impurity in the water. So the oil will break the surface tension. So when the mosquito comes and lays eggs on the surface of water, the eggs cannot float. Therefore, they are going to sink. So that is a way of controlling mosquito breeding, using oil. When you oil the surface, what happens? The oil is an impurity. So it breaks the surface tension of water. Therefore, any mosquito coming to lay eggs on the surface, the eggs will not float on the surface. And therefore, they will sink. And there will be no hatching. And you will have broken the cycle of a mosquito. So those are what you are calling effects of surface tension. Now, let's move to our last type of force. Our last type of force, we call it action and reaction force. Action and reaction force. action and reaction force. This is our last category, our last type of force. Now, which force is this? Now, in details, we are going to meet this force in Form 3. We shall learn about this type of force in Form 3 and a topic to do with the Newton's laws of motion. As we understand, we learned about Isaac Newton earlier in primary school. We met Isaac Newton in primary school, science. So we know who he is. He is the one who came up with force. He discovered forces. Now we shall learn about action and reaction force in details in Form 3. But at our level, what is action and reaction force? Now, action and reaction force are equal and opposite forces. Action and reaction force are equal and opposite forces acting on a body. These are forces which always occur in pairs. Whenever one occurs, the other one is going to occur. Now, a simple demonstration of what action and reaction force is this. This duster, when I place it on the surface of my hand, because of the weight of the duster is acting on my hand. And that is an action force. In other words, the duster presses itself against my hand. And therefore, I can feel some pressing, I can feel some weight, the heaviness of the duster on my hand surface. This is as a result of what a force we are calling action force. The action force in this case is the weight of the duster. The duster is pressing on my hand surface. Likewise, the hand presses back on the duster. As the weight of the duster is pressing on my hand surface, my hand presses equally on the duster in the opposite direction. And because of the weight of the duster is acting on my hand, pressing it downwards. So the hand will react, producing an equal force on the duster in the upward force. So the action is the duster on the hand. The reaction is the hand on the duster. So those are two forces which are acting at the same time. And they are acting in the opposite direction. The duster is acting downwards on my hand is acting upwards on the duster. And these two forces are always equal. So our demonstration is a block on the surface This is a block on the surface. The block has weight. The weight of the block is acting on the surface. And that is what you are calling the action on the surface. Now, the surface has to provide an equal force in the opposite direction. And that force is reaction. So that is the reaction of the surface on the block. Another demonstration of action and reaction force. We have what we call the sprinkler, the farm sprinkler. In the sprinkler, our sprinkler has got that is a sprinkler. That is a hose pipe. The hose pipe is letting in water. Now, what happens is this. As the water flows in through the hose pipe, reaching this end, some water flows towards this direction, the other water flows in this direction. There's something you're going to notice. As this water flows out with a lot of pressure, you'll notice something. The water comes out of the hole with some force. So there is an action force on the pipe in this direction. So the pipe experiences a force pushing it in that direction as the water comes out. Similarly, this end will receive a force, will experience a force pushing it in the opposite direction. As the water acts in this direction, the reaction force will be acting in this direction. And what happens? This will make the sprinkler to do what? To start rotating. That is action force in action, and we have a reaction. So these forces always act in pairs. If somebody punches you on the cheek, he is acting on your cheek by exerting the force, using the blow on your cheek. The cheek has to provide a reaction force on the hand equivalent to the action on your cheek. So the blow is acting on your cheek will react by providing an equivalent force on the hand. So those are action and reaction forces. So when one body acts with a certain amount of force, that surface has to provide an equivalent force, a reaction force. So I said in details, we shall learn about the action and reaction force in Form 3. Now, to do with forces, I'll give you some questions for your trial. Please try these questions, students. And you can send your answers to the right channels, you know them. Send your answers to the right channels for clarifications and corrections. Exercise, students. Attempt these questions. Number 1. State 2 factors affecting surface tension. Question 2. Name 2 ways of increasing surface tension. Question 3. Explain the 2 factors affecting surface tension. Lastly, question 4. Name 2 ways of lowering surface tension. Please, students, try these questions. Try answering those questions based on our explanation, based on our discussions in the previous subtopic about forces. Now, let's move to our next subtopic, which is mass and weight. Mass and weight. Mass and weight. Mass and weight. These are quantities. We have met mass previously. We discussed mass previously in our topic measurement 1. In measurement 1, we said mass is a basic physical quantity. And we said mass being a basic physical quantity, its SI unit is kilograms. So now we are bringing in another quantity here, we are calling it weight. And we want to see what's the difference between weight and mass. Now, mass, we define it as the quantity. Mass is the quantity of matter in a substance. That is how we define mass. Mass is the quantity of matter in a substance. Weight. Weight is the pull of gravity on a body. Weight is the pull of gravity pull of gravity on a body. The pull of gravity on a body is weight. The quantity of matter in a substance is what we are calling mass. We know that based on measurement 1, that we said mass is measured in kilograms. The SI unit of mass is kilograms. But what about weight? The SI unit of weight is newtons. Now, in a simple way, I'll give a table here giving us the differences between mass and weight. The differences between mass and weight, or comparison. Comparison between mass and weight. How do the two compare to each other? Number one, we have said that mass is the quantity of matter in an object. Mass is the quantity of matter in an object, while weight is the pull of gravity on a body. Pull of gravity on a body. That is our first comparison. If you compare mass and weight, you find that mass is the quantity of matter in an object. In other words, how many particles are contained in a body. That is mass. But weight, it is the pull of gravity on a body. When you talk of the pull of gravity, we have discussed a force called gravity. We said this is a force of attraction between bodies of different masses. And we said that any object near the Earth's surface or on the Earth's surface, it experiences a force which always pulls it towards the center of the Earth. But we said that this force depends on several factors. It depends on the mass of the object itself. The weight, therefore, depends on the mass. Because we are saying that weight is the pull of gravity on a body. All objects on the Earth's surface, they experience a pull. And the pull is a pull of gravity. And we say the bigger the body is, then it is going to be pulled with more force. So what happens is, we understand the Earth's surface. An object here is being pulled. This is the Earth's surface, which is regular depending on mountainous areas, valleys. So this object is being pulled by a force. Its mass, and this is the mass of the Earth. So a body on the Earth's surface is being pulled towards the center of the Earth. And this force pulling the two is what you are calling the gravitational force, gravitational pull of Earth. Now, any kilogram of an object on the Earth's surface is pulled by a force of approximately 10 newtons. Student, get this one very clearly. Any object on the Earth's surface is pulled by a force. Any object whose mass is 1 kilogram on the Earth's surface or near the Earth's surface, it is pulled by a force of approximately 10 newtons. Any object on the Earth's surface is pulled by a force of approximately 10 newtons, as long as that body is of mass 1 kilogram. And for that matter, it means that there is what we call gravitational field strength. Gravitational field strength. This is the strength of the Earth's gravity pulling any object on the Earth's surface. And you find that we have seen here that if 1 kilogram of a substance is being pulled by a force of 10 newtons, therefore, gravitational field strength will be denoted by G, and it is equivalent to 10 newtons per kilogram, approximately. The accurate value is 9.8 newtons per kilogram, but we are saying approximately 10 newtons per kilogram. Let's get back to our table. The differences between mass and weight. Number 2, mass is measured in kilograms. In brackets, small k, small g. Weight is measured in newtons. In brackets, capital N. Number 3, that mass is constant. When you talk of mass being constant, we said mass is the quantity of matter in an object, the number of particles contained in your body. If your body is made up of 1 million particles, then that number of particles cannot change if you move from one part of the earth to another. If you move from one heavenly body to another, you still be having the same number of particles in your body. So that's why you are saying that mass of a body is constant. The number of particles contained in a body cannot change. If you are having 5 million particles in your body on Earth, you still be having 5 million particles in your 5 million particles in your body when you go to Moon, when you go to Saturn, when you go to Venus, you go to Mars, or any other heavenly body, you go to Moon. The number of particles in your body do not change. So mass is constant. What about weight? Weight is not constant. Weight varies from one heavenly body or one place to another. From one place to another. Weight, unlike mass, weight changes from one place to another. Why? Weight is the pull of gravity on a body. Weight is the pull of gravity on a body. Therefore, this pull of gravity, we saw when we are learning about gravitational force, that the pull of gravity varies from one place to another. Because the pull of gravity depends on how closer or how far are you from the center of the earth. So the pull of gravity varies from one heavenly body to another. And we say the smaller the heavenly body, the smaller the pull of gravity on it. The bigger the heavenly body, the bigger the pull of gravity on it. So you find that an object's weight on Earth will be different from the object's weight on Moon. An object's weight on Mars is different from an object's weight on Jupiter or any other heavenly body, because these heavenly bodies have got different pools of gravity. They have different gravitational force. So weight, since it depends on the gravitational pull, weight, because it is a pull of gravity on a body, this pull of gravity on a body varies from one place to another. The pull of gravity on Earth will be different from the pull of gravity on Moon, will be different from the pull of gravity on another planet or anywhere. Now, that is why we are saying that weight varies from one place to another. Mass is constant. Student, get it clearly that mass is constant, but weight varies. But the other question will be, explain, why is mass constant? We have said mass is constant because the number of particles in a body does not change. If your body has got 10 million particles, whether you are here, you go to America, you go to India, you go anywhere, now decide to move from Earth and go to Moon, your number of particles remain the same. The particles in your body do not change. That is why your mass will not change. But now your weight changes. Why? The weight of a body changes because the gravitational pull will change. That each heavenly body has got its own gravitational pull, which depends on its size. So because of the changing gravitational pull, the weight of a body changes. Number 4, another comparison between mass and weight. Another comparison between mass and weight. Our comparison number 4. We say that mass is measured using a beam balance. Mass is measured using a beam balance. I think we learned that in measurements topic, in our previous topic on measurements. We learned about mass, and we said there is an instrument used to measure mass. Mass is measured using an instrument called a beam balance. We talked of the types of beam balance. We said we have 2 types of beam balances, 2 categories of beam balances. We have mechanical beam balances and we have electrical beam balances. I hope students, you still remember that. Now, number 4, on the side of weight, that how do you measure weight? There is an instrument used to measure weight, and this one is called a spring balance. Weight is measured using a spring balance. Weight is measured using a spring balance. Number 5, we say that mass has magnitude only. It has magnitude only, while weight has magnitude and direction. So mass has magnitude only. Magnitude is size. How big is the mass? How big is your mass? Your mass is 50 kilograms, your mass is 80 kilograms, that is your magnitude. So mass has magnitude only. But when it comes to weight, it has magnitude, it has direction. It has magnitude, it has direction. I refer to your weight. Your weight, it must have in direction because it depends on the pull of gravity. And the pull of gravity, we understand, is a pull towards the center of that particular heavenly body. So this table gives us a comparison between mass and weight. So you must know. Now from this table, we can come up with differences. We have the differences between mass and weight. We have the similarities. And in most cases here, all these are given out are the differences between mass and weight, in terms of the units, in terms of the instruments used to measure, in terms of what they contain. That mass has magnitude only, while weight has got magnitude as well as direction. So students, you must be able to master that table very well and know how to differentiate mass and weight. Now, when we talk of magnitude and direction, I've said magnitude refers to size. How big is the mass? I can refer to a mass of 5 kilograms, a mass of 10 kilograms, a mass of 50 kilograms. That is the size of mass. But when it comes to weight, as much as I'm talking about it in terms of direct magnitude, a weight of 50 newtons, a weight of 500 newtons, I can also refer to it in terms of direction because it depends on the pull of gravity. Now this is leading us to something else which we are calling quantities. We have what we call vector quantities and scalar quantities. Vector quantities, vector and scalar quantities. And these ones will form part of our next lesson, students. In our next lesson, therefore, we shall be learning about the vectors and the scalar quantities. And these are quantities which are now giving us the differences between mass and weight as difference number 5. So our lesson will end there, but now prepare for our next lesson to do with vectors and scalar quantities. Thank you so much, students. Meet you in our next lesson. Bye.